on chapter 20, Inference about a population mean. This is the similar thing what we discussed in chapter 17. We can say the same but little changes. Okay, you see assumptions. We do assume we have simple random sample and it has normal distribution with mean mu and standard deviation sigma. So last time we assumed sigma is known, but this time we assume both mu and sigma are unknown parameters. In the chapter 17, we assume mu is unknown but sigma is known, right? But here we assume both are unknown. Then we define new definition here, standard error. Standard error of the sample mean is x bar, you know sample mean x bar. Standard error of that is s over root n. S over root n. What is the s? S is the standard deviation. Yes, if sigma is unknown, that is unknown, then we can use s instead of sigma. What is the sigma? Sigma is the population standard deviation. S is the sample standard deviation. S is the estimate of sigma. Therefore, we can use s. So, how do we calculate s? S is summation xi minus x bar to power 2 divided by n minus 1 and square root. That is the s. So last time we use z equal x bar minus mu sigma over root n because sigma was known. Therefore we could use sigma. But in this case sigma is unknown. Therefore, instead of sigma, we use s. You see that it is the same thing, but we use s. And z become t then. Okay, that is the t distribution. So again, last time we used z. Now this time we use t. So this meaning this whole part t equal x bar minus mu over s over root n has t distribution with degrees of freedom n minus 1. So that's why say n minus 1 degrees of freedom. Okay. Now you understand the difference, right? Instead of sigma, we use here s. When we use s, we should use t distribution, not z distribution. Okay, right. Then confidence interval. So could you remember the confidence interval when we use z? That was x bar plus or minus z star sigma over root 10. This was the confidence interval when you know the sigma. We use the z again, right? Z star. But now sigma is unknown, so we use s and we use t star here instead of z star. Okay, we use t star. So let me explain this using some examples. But before we go to confidence interval, we should know how to use the t table. What critical value t star would you use for a confidence interval for the mean of the population in each of the following situations? So 95% confidence interval based on n equal 12 observations. Now you know confidence interval is x bar plus or minus t star s over root 10. How do we find the t star here? First, we should know the degrees of freedom. Degrees of freedom always is 9n minus 1. Here n equal 12 and minus 1, which is 11. That is the degrees of freedom. First you need to find the degrees of freedom. Then go to the confidence level. It is 95%. That is C, right? It is 95% confidence level. Right. Now let me go to the T table. And degrees of freedom was 11. It is 11. This column you see degrees of freedom. Right. And here confidence level. Right. Our degrees of freedom is 11. So we consider this row. Okay. It is 11. Now go back and check the confidence level. What is the confidence level? It is 95. Therefore, go to the 95 here and go down, and this is the 11. And what is the intersection? 2.201. Right? 2.201. Okay, understand this table. In the Z table, in the middle of the table, we had the probabilities. But here not the probabilities, but T values. And again, you see this is the confidence level, and these are the degrees of freedom, and here in the middle of the table, you see the T values. Right. For our case, T star is 2.201. 2.201. Therefore, we can say T star equal 2.201. So that is the T star. That's the way we find the T star. So next one, a 99% confidence interval from a simple random sample of 2 observations. Right. Again we need the degrees of freedom. It is n minus 1 is 2 minus 1, which is 1. Okay. And 99% confidence interval means confidence level is 99%, 0.99. Go back to the T table. 0.99 is, you see, 99%. It is here. And degrees of freedom is 1. So T star is 63.66. So we can say T star is 63.66. Here 90% confidence interval from the sample size 1001. Degrees of freedom n minus 1, it is, it is 1000. And confidence level is 90%. So go back to the table. 90% is this. You see that. Then 1000. You see it is here. Degrees of freedom 1000 is here. So the number T star is 1.646. 1.646. Therefore, T star equal 1.646, right? 646. Now you understand how to find the T star. Now let me explain this example. Here, read the example first and understand the given informations. So what are the information we have here? You see 24 young adults. Yeah, you know how many data we have here, 24. Therefore, we can say n equal 24. Sample size is 24. Now main thing is check for the population standard deviation or population variance. Do you see the population variance here? No, it is not given. Okay, you understand now. It is not given. Population variance is not given or population standard deviation. Therefore, we know we should use T. Okay, therefore, the confidence interval X bar plus or minus T star S over root 10. So that is the confidence interval. We have only data set and they are asking to find the 99 confidence interval, 99%, right? Then that is the C equal 0.99, then alpha equal 1 minus C, which is 0.01. Okay, right. Now we need to find the x bar. How do we find the x bar? We have a data set, then you know how to find the x bar. So x bar equal, add them together, and all of them divided by number of data here, 24. So this x bar is 62.167. So that is the x bar. Yes, we can plug the x bar here, 62.167 plus or minus. Then we need T star. How do we find the T star? To find the T star, we need degrees of freedom. What is the degrees of freedom? Degrees of freedom equal n minus 1. Here n equal 24 minus 1, then 23. And confidence level. We know confidence level is 99. Therefore, go to the 99 T table and 99%. See, it's a 99. So 23, right? This is the 23. And 99 is here. You see, then you get this 2.807. Right? That is the T star. So 2.807. Then we need to find the S. How do we find the S? As I mentioned at the beginning of this chapter, the S is summation xi minus x bar to power 2 divided by n minus 1 square root. So this is actually chapter 2, right? So using this equation, you can find the S. So I just show you couple of data here. So you can say 65 minus 62.167 to power 2 plus you can go to the up to 70 minus 62.167 power 2 divided by 24 minus 1 and get the square root. So you have to do for each point, right? For the top part. Yeah, for the test, no worry that this many, okay, this many points, maybe 5 points maximum, right? So then you can, because then I can check whether you know this S, how to find the S and other part. So this is 5.806. That is the X, 5.806. So now we know 5.806 divided by n is 24 and square root and this. So this is the confidence interval. Now we can simplify. So 62.167 plus or minus, this is 3.327, okay, 327. Then we can write the confidence interval 58.84 and 65.49. That is the confidence interval for mu when sigma is unknown, right? That means you know the meaning of this one, 58.84, 65.49. So mu should be in between these two numbers. That means in this interval somewhere here. So that is the meaning of the confidence interval. Now again, when we use sigma, we write x bar minus mu naught sigma over root 10. But when we use s, sigma is unknown, it becomes s here and this becomes z become t. Right? That is the one sample t test. We use this for the hypothesis testing. Okay, so you know the steps are the same in chapter 17. Okay, so first we use the assumptions, you know, normal distribution, and here sigma and both mu and sigma are unknown, so you use the same thing. The rest you see that here defining the hypothesis. Yeah, same hypothesis you see. We have that choice 1 is the two-tailed test. This is the two-tailed or two-sided, and other two are you see these two one-sided, and this one is right tail. You know this is right, therefore right tail, and this one is left tail because of this inequality. So that is the first thing, the same thing like chapter 17. Then we go to the test statistic. Test statistic is is the similar, but we use S and we use T naught instead of Z naught. Understood that? Those are the differences of the test statistic. Okay. Now you should have an idea what is that. When you know the sigma, you use Z table. When you don't know the sigma or sigma is unknown, then you use T table. Sometimes you know you have a data set, but instead sigma is given. Understand that? Sigma is given. Then you use the Z table. Okay? If sigma is known, use the Z table. Okay? Not this one. Right. Then how do we find the p-value? You see there, this look the same in chapter 17, but the difference is here we use T instead of Z. Okay, the similarly you see the all three cases, the similar to the chapter 17, but we use T. I will explain how to use the T table to find the p-value, but this is the concept. Okay, so read this. So that's the same thing I explained, so you can understand more clearly. And other one is the conclusion. We reject H naught. We reject H naught. P-value is less than or equal alpha. That is the conclusion. The same thing what we used the last time. P-value less than or equal alpha. Then we say reject the H naught. Alright. So let me explain this before we go to the problems. The one sample statistic for testing H naught mu equals 0 and versus HA mu less than 0. So what is this? This is a one tail or one-sided, right? One-sided test. Okay. Then n equal 25. Then T naught. What is the T naught? It is the test statistic. T naught equal x bar minus mu naught s over root 10. So this is 1.75. That is the T naught. Okay, it is given. Okay, it is given. Right. Now, what are the degrees of freedom? Okay, how do we find the degrees of freedom? You know, degrees of freedom is n minus 1, then 25 minus 1, it is 24. That is the degrees of freedom. Then give the two critical values T star from the table. Why are they asking two critical values? In the chapter 17, we had only one critical value. Okay, but now they are asking two critical values. So, how do we find the two critical values? So, let me explain. Okay, now our degrees of freedom is 24. Okay, degrees of freedom is 24, and our test statistic, which is T naught, is 1.75. Okay, right. Now T naught is 1.75, degrees of freedom is 24. Then go to the table and get the 24 degrees of freedom. So then check the row, this row, and check for the 1.75, because 1.75 is the T naught here. You see that T naught. Check for that number. Can you find the 1.75 here? No. But 1.75 should be in between this number. Right? 1.75 should be in between them. Right. Therefore, we can say T1 star is 1.711 and T2 star is 2.064. These are the two critical values they are asking. Okay, so T1 star is 1.711 and T2 star is 2.064. Right. Now they are asking what are the p-values, one-sided p-values for these two entries. Yes, next step is to find the p-values. So to find the p-value, first you need to understand the alternative hypothesis. It means HA. It was one-sided or two-sided? It was one-sided, right? Therefore, go to the bottom of the table, you see one-sided p-value, this one. Because of one-sided test, we consider that row. Okay, so then go down, check the p-values corresponding to this number, that is one-sided. Therefore, this 1.05 and this 1.025. 0.05, and so we can say this number 0.05 and this one 0.025. What is the meaning of this? Now understand the meaning of this. Our T naught here, T naught was 1.75. It should be in between these two numbers. Normally we need to find that the p-value corresponding to this T naught, right? But we couldn't find this number in the table. Therefore, we have two critical values and two p-values. Then p-value we are looking for should be in between these two. Understand that one? P-value corresponding to T naught should be in between these two p-values. Okay, right. That means I can write this way: p-value corresponding to the T naught should be in between 0.025. You see, this is the smallest number. Okay, you see that is the smallest number. It is the opposite for the T values. Okay, in T value this is the smaller one, but P value this is the smaller one. Then in between 0.025 and 0.05. That is the P value. Okay, that is the P value. Right. Now you should understand this. P value should be less than 0.05 and greater than 0.025. Okay, you need that for the next part. Here is the value T naught 1.75 significant at 10% level. Okay, 10% level mean alpha equal 0.1. Now, how do we check significant or not, or H0 is rejected or not? So, how do we know that? If p-value less than alpha, we say what? Reject less than or equal, right? Reject H0. Reject H0. Understand? So, that is the condition for the conclusion, right? Right, alpha equal 0.1. Then you know here p-value should be in between 0.025 and 0.05. From this, we knew that in the before, right? Now alpha, you know, p-value should be somewhere here. We don't know where it is, but we know only one thing, in between 0.025 and 0.05, in that interval. Then alpha equal 0.1. Alpha equal 0.1, it is greater than 0.05, right? Right. Alpha 0.01, therefore alpha should be somewhere here. Got it? Alpha should be somewhere here. Then you know alpha is greater than the 0.05. Alpha is greater than 0.05. And you know p-value is less than, you see p-value is less than 0.05. And now we understood alpha is greater than this. Therefore, we can say p-value less than alpha here. Understood that? So then what is the conclusion? We can say H0 is rejected. H0 is rejected. So that's the way we come to the conclusion. Okay, that's the way we come to the conclusion. This is not easy like Z table, but once you understand, it is nothing. Right. For next one, they are asking, is it significant at 5%? Alpha equal 0.05. That is alpha. Then how do we do this one? Then again, you know, this is 0.025, we know, and this is 0.005. So p-value in this interval, and alpha equal 0.05. That should be this one, the same thing, right? Alpha equal 0.05. The upper bound, you see that 0.05, it should be the same, right? But still you know 0.05 greater than p-value. We know that one, right? And how do we know? Because p-value in between here, right? It is not the 0.05, it is not the 0.025, in between them. Therefore, according to this, we can say p-value less than alpha 0.05. Now we can decide H0 is rejected. Next one is alpha equal 1%, mean 0.01. How do we check for this alpha? You know 0.025 is here, 0.05 is here. So alpha 0.01, that it is less than 0.025. Therefore alpha should be somewhere here, less than 0.025, right? So again we know p-value should be in between these two numbers. Now what is the condition here? Actually, you see p-value now greater than alpha. Therefore our conclusion is what? H0 is not rejected. So that's the way we come to the conclusion. Here the case is different, right? Because alpha is less than the lower limit. That means p-value is greater than alpha. Okay? Suppose alpha equal 0.025. then it's still here, right? It's still, suppose alpha equal 0.025, then it's still same conclusion. P value can't be 0.025 and P value can't be 0.0052 as well. Understand? Tell me the answer for this one. If alpha equal 0.03, what is your conclusion? If alpha equal 0.03. Yes.
Would it be rejected because it's between the two values?
It is in between the two values. You are right at that. It means, let me show you 0.025 here and 0.05 here. So alpha may be over here 0.03, right? Alpha. That's right.
But you don't know which part.
Exactly. You don't know where the p value is. P value may be here, or maybe here, or maybe the same. Who knows that? Therefore, can you come to any conclusion? No. If you get alpha in between in this interval, then actually we cannot make any conclusion. Understand that? Let's say we cannot come to the conclusion. Okay? That's the only thing you can do. Alright. Any questions? If not, let me explain this one. The one sample statistic, you know, this is a two-sided test and n equal 5. And T naught is this. What is the T naught? That is the test statistic, right? So then asking degrees of freedom, you know, degrees of freedom equal n minus 1, n equal 5 minus 1, which is 4. That is the degrees of freedom. Then asking to find the two critical values. To find the two critical values, what do we need? We need T naught and degrees of freedom. T naught is 2.5, degrees of freedom is 4. Go to the T table and go to the degrees of freedom 4. It is here and 2.5, right? 2.5. Can you find the number 2.5 in this row, this column? Sorry, this row, right? This row? No. But you know 2.5 should be in between that. Got it? Yeah. Therefore, 2.132, 2.132, and T1 is equal 2.132 and T2 is equal, next number, 2.776. 2.776. And we know T naught should be in between these two numbers, 2.5. Okay. Then we need to find the p-values. How do we find the p-value for the two-sided? It is the similar, but let me explain the difference. You see, now it is two-sided, right? Not one-sided test. Therefore, we should consider the two-sided part. So you see here two-sided p-value. Therefore, come from here and you see this is a two-sided 0.1 and this is 0.05. Understand that? 0.1 and 0.05. So we will go from here, this is 0.1 and this is 0.05. So we can write p-value corresponding to T naught, which is 2.5, is less than 0.1 and greater than 0.05. So now we know this. We know actually a range for the p-value. Knowing a range, we can decide the conclusion. We can come to the conclusion. Got it? Then, is the value T naught statistically significant at the alpha equal 10%, that means 0.1. Okay, So let me draw this. This is 0.05 and this is 0.1. Yes, you see alpha is also 0.1 coincide, right? Therefore we can say, before that, p value should be somewhere here. Under this condition, you see p value less than alpha 0.1, therefore H naught is rejected. H naught is rejected. You see that? Right. So similarly, alpha equal 0.05. Yeah, you see here, this is 0.05 and this is 0.1 and alpha also 0.05. But p value should be somewhere here. Therefore, we can say p value in this case greater than alpha, which is 0.05. Therefore, H naught is not rejected. Okay. Then 1%. Alpha equals 0.01. Then we can say this is 0.05, this is 0.1 and 0.01 should be somewhere here, right? We just compare numbers, okay? So then we can say p value in this case also p value greater than alpha 0.01. Therefore H naught is not rejected. Yeah, same thing, similar thing over here. Please you can do this. Okay, similar thing asking that. And yes, so let me go to the exercises. Actually here I explain example. Okay, here I explain example. So I think you have all the steps here, so please read it, go through this. I am not going to explain this because everything is there, so I explain it step by step so you can understand. But you see even table how to find it, I explain this way so you can understand. You see everything here. But let me go to the one more thing here. Actually, suppose here actually you see degrees of freedom is 58, but we cannot find the 58 in the table. So what to do then? You just go to the closest one. This is the 60, that's why we use 60. Got it? Yeah. So conclusion, yes, as I explained before, I will come to match pairs t-test later. Okay, please remind me. Okay, if I will explain that later. But let me explain these problems. Okay, because you have to understand this very clearly before we go to the match pair. Find the p-value when the t-test value is 2.056. Okay, t not equal 2.056. 2.056. The sample size is 11. N equal 11. Before we go to the table, we should know degrees of freedom. It is n minus 1, which is 11 minus 1 is 10, right? It is a 10. Now we need to check 2.056 on the row corresponding to n equal 11, right? N equal 11, this one 2.056. Can you find the 2.056? No, right? We don't see that, right? 2.056. No, 2.056 should be in between these two. Yes or no? Yes. So but it's a p value when t value is and the test is right tail. Okay, it's a right tail. It doesn't matter right or left tail, but one sided, right? Therefore, go to the one sided. Go to one sided, this one, and then this one 0.05 and 0.025. Therefore, we can say p value less than 0.05 and greater than 0.025. That is the p value. Next one. Oh, it is right. Degrees of freedom 10, right? Which I check. Actually, degrees of freedom 10, not this. Yes. Because here you see degrees of freedom is 10. So therefore, consider 10 and 2.056. Can we find a 2.056? No, but we know it is this, right? 2.056 should be in between that, but it is the same, right? 0.05, 0.025, 0.025, 0.05. Find the p value when the t-test value is this. The sample size is 6. Okay. Then we need again degrees of freedom for this case. It is n minus 1, that is 6 minus 1, which is 5. Then go to the degrees of freedom 5. It should be here. And go to the 2.983. Can you find the 2.983? No, we cannot, but we have 2.983 in between this. Once you decide that part, we need to check the alternative hypothesis. So it is test is two-tailed. Yes, therefore go down here, and this is the two-tailed. Therefore 0.02 and 0.04. It is p-value greater than 0.02 and less than 2.04. Got it?